2025 A-Level Combined Mathematics Paper 1 Part B, question number 13, Part C. Part A of this question was discussed in a previous video, link in the top right, and Part B of this question was also discussed in previous video, link in the top right. Part C of this question is relatively short compared to those two, and it has to deal with complex numbers and De Moivre's theorem. The question says, let m be an element of the positive integers, and it is given that 1 plus the square root of 3 times I to the power of 3m times 1 plus I to the power of 8 is equal to 2 to the power of 3m plus 4. And then it says, find the least value of m. So what we need to use here, the theorem, De Moivre's theorem, states that if you have a complex number of the form cos theta plus I sin theta, where theta is some element of the real numbers, and you raise it to some power n, the corresponding value, the complex number value that this is going to be equal to is the cosine of n times theta plus I times the sine of n times theta. Now this is a specific case of the general form where you have cosine of, let's say, alpha plus I sine alpha being one complex number with unit length, and you multiply by another complex number which is cosine of, let's say, beta plus I sine of beta sine beta, and then the result of this is going to be the cosine of alpha plus beta plus I times the sine of alpha plus beta. So you can see, if alpha is equal to beta and you do this repeatedly, you repeatedly multiply again and again, this is going to turn into cosine of n times that angle plus I times the sine of n times that angle. So therefore, this is what De Moivre's theorem is. Now, in order to apply De Moivre's theorem into this case, what we need to do is to convert this complex number here and this complex number here into the form of r times cos theta plus I sin theta, where r is the size of the complex number and cos theta and I sin theta have an angle theta which is the eigenvalue of that complex number. So we need to convert this complex number into that form and this complex number into that form in order to apply De Moivre's theorem using the powers of 3m and 8. Now, if we do that, 1 plus the square root of 3 times I can be converted into that form by taking a 2 out and dividing by 2. If we do this, we take a 2 out and divide by 2, we get a half plus the square root of 3 divided by 2 times I. Now, in order to express this part here in terms of cos theta and I sin theta, what we need to do is to realize that if you consider the cosine of pi by 3 and the sine of pi by 3, the cosine of pi by 3 is equal to half and the sine of pi by 3 is equal to the square root of 3 over 2. So therefore, this is in fact the cosine of pi by 3 plus I times the sine of pi by 3. So here we have the form where this is the modulus of the complex number and this right here is what we want, which is the cosine of some angle plus I times the sine of some angle. Now similarly, for the other complex number 1 plus I, we can convert 1 plus I into that form by multiplying and dividing by the square root of 2. So if we multiply by the square root of 2 and then divide by the square root of 2, internally we're going to get 1 over root 2 rather, and then plus 1 over root 2 times I. Now, 1 over root 2 is equal to the cosine of pi by 4, and 1 over root 2 is also equal to the sine of pi by 4. So therefore, this could be written as equal to the square root of 2 times the cosine of pi by 4 plus I times the sine of pi by 4. Now, what we're going to do is to take this as equation 1, take this as equation 2, and we're going to substitute equation 1 and equation 2 into this thing in order to simplify it down and get an equation that we can use to then find m. So if we substitute those into here, we can see if 1 plus the square root of 3 times I to the power of 3m times 1 plus I to the power of 8 is equal to 2 to the power of 3m plus 4, then if we substitute 1 and 2, doing 1, 2 and substituting, we get that 1 plus the square root of 3 times I is 2 times the cosine of pi by 3 plus I times the sine of pi by 3, and that needs to be raised to the power of 3m, and then substituting the other one, 1 plus I is equal to all of this, so we can say this is times the square root of 2 times the cosine of pi by 4 plus I times the sine of pi by 4, and all of this is raised to the power of 8, and this whole thing needs to be equal to 2 to the power of 3m plus 4. So this whole thing is equal to 2 to the power of 3m plus 4. Now we can see by index rules, if we simplify, this 3m to the power of 2 is going to become 3m to the power of 2 separately, and the square root of 2 to the power of 8 is going to become 2 to the power of 4. Therefore, this is equal to 2 to the power of 3m. I'm going to take the square root of 2 to the power of 8 as multiplied by 2 to the power of 4, and the rest of it is going to turn into this bit, which is going to be the cosine of pi by 3 rather, plus I times the sine of pi by 3 to the power of 3m times the second bit, which is the cosine of pi by 4 plus I times the sine of pi by 4 raised to the power of 8, which is equal to 2 to the power of 3m plus 4. Now what we're going to do is use index rules to cancel this out with this, since 2 to the power of 3m times 2 to the power of 4 is simply 2 to the power of 3m plus 4, so we can cancel both sides since it's not equal to 0, and then we get that the cosine of pi by 3 plus I times the sine of pi by 3 to the power of 3m times the cosine of pi by 4 plus I times the sine of pi by 4 to the power of 8 must be equal to 1. Now, we can use de Moivre's theorem here to simplify this thing and this thing into much easier to use terms. So we can say, using de Moivre's theorem, which we don't need to state, we can just state that we're using it at only, and then we can write our answer. We don't need to write what de Moivre's theorem is, we can just apply it. So from what we know from de Moivre's theorem, this first part is going to become cosine of pi by 3 times 3m, which is going to simplify down to cosine of m pi. Similarly, the plus I times the sine of the angle is going to become plus I sine pi by 3 times 3m, which is going to be just plus I times the sine of m pi. The second part here is going to turn into the cosine of pi by 4 times 8, which is going to be the cosine of 2 pi plus, and then we get I times the sine of pi by 4 times 8, which is going to be the sine of 2 pi, and this is equal to 1. Now, if we go to the next page and we simplify this down, the cosine of 2 pi is equal to 1. The sine of 2 pi is equal to 0. Therefore, if we simplify this, we can get that this is equal to the cosine of m pi plus I times the sine of m pi multiplied by this thing, which is going to simplify to just 1 plus 0i, or just 1 plus 0, which is equal to 1. So therefore, the cosine of m pi plus I sine of m pi must be equal to 1. Now note, the real parts and imaginary parts of the left hand side and the right hand side must be equal. So therefore, on the left hand side we have a real part of cosine m pi, we have real part of 1 on the right side, so therefore the cosine of m pi must be equal to 1, and we also know that the I times the sine of m pi must be equal to the real imaginary part of the right hand side, which is 0, which we don't really need to write. We can just use this and simplify it down, but if you want, you could write that part as well. But moving on, we know that the cosine of m pi must be equal to 1. Now, 1 is also equal to the cosine of 0, which means that the cosine of m pi must be equal to the cosine of 0. Now, with this kind of relationship, we know that if the cosine of one angle is equal to the cosine of another angle, this only happens if the first angle is equal to 2n pi plus or minus the second angle, so plus or minus 0, where this n here is some element of the integers. So from this we can see that m pi must be equal to 2n pi plus or minus 0, which then means that m pi must be equal to 2n pi, where n is an element of the integers. Now note, if we cancel out the pi, we can see that m must be equal to 2n, where n is an element of the integers. Now, this is a point where a lot of students might get the wrong answer. If we go up here, we can see that m is an element of the positive integers. And furthermore, we are asked to find the least value of m. So the least value of m for m being a positive integer comes from n also being an element of the positive integers, because if n is just an element of the integers, n could be 0, in which case 2n is 0, in which case m could be 0. But since m is an element of the positive integers, the least value of m is equal to the least value of n times 2, which in this case when n is a positive integer is going to be 1. So we have 1 times 2, which means that the least value of m is equal to 2, and we can say since m element of the positive integers. So therefore least value of m is equal to 2. Now this identification here is very important, because without this the least value of m could go all the way to negative infinity, because if this was just the condition, then n could be any integer, which means that n could be negative integers, which means the largest negative value, or the least value, the minimum value, the lowest value of m would be negative infinity. But avoiding that, since m is a value which is an element of the positive integers, n equals 0 doesn't work, since that would be 0, which is not an element of the positive integers. The next value of n which is greater than that is n equals 1, in which case we get 2 times 1, which is 2, which means that the least value of m is equal to 2. So that's going to be all for this question. Finally, let's discuss the marks awarded for this question. So at the start, when you identify that this can be solved by de Moivre's theorem, and then you convert this into the form r times cos theta plus I sin theta, and this into the form r times cos theta plus I sin theta, you're going to get 5 marks and 5 marks for the first conversion and the second conversion. After that, when you then simplify this down and you take the 2 to the power of 3m and 2 to the power of 4 factors out, and you factorize it like this, you're going to get 5 marks at this point. When you then further simplify that down in order to get this form, and then realize that you're going to get this bit right here, either here or here, you're going to get 5 marks. And finally, when you simplify that down and you get the case that m pi is equal to 2n pi, where n is some element of the integers, which means that m is equal to 2n, where n is some element of the integers, and you finally get that the least value of m is equal to 2, since m is a positive integer and not just any integer, you get another 5 marks. So that's going to be all for that question. I hope you enjoyed. As a special note, I should apologize for my pronunciation of de Moivre. I don't exactly know how to pronounce it. I believe it's pronounced de Moivre, so something like that. So that's going to be all for this video. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.